So when we talk about prime factorizations, we're talking about taking a number and writing it in terms of its prime factors. There's a couple ways to do this, but I'll show you one way. It's called using a factor tree. So say we have the number 36. We think of any two numbers that multiply to be 36, maybe 3 times 12. It doesn't matter what two numbers you start with. It's going to work out in the end. 3 is a prime number, so we're going to stop with the 3, but 12 is not prime. So we'll break that up into two things that multiply to be 12. Say 2 and 6. 2 is a prime factor, but 6 is not, so we'll break 6 up into 2 times 3. Since 2 is prime and 3 is prime, we're done. We've found the prime factorization. It's all those numbers that I have circled. We can write it as 2 times 2 times 3 times 3. Or if we want to use our exponents, we can write 2 squared times 3 squared. If we were to multiply 2 times 2 times 3 times 3, it would equal 36, the number we started with. And this is called a prime factorization. Another way to do it is to start with your number 36. And if 2 will go into it, we're going to divide it by 2. If 2 doesn't go into it, you go to the next prime number. But 2 is our smallest prime number. 2 goes into 36 18 times. We see if 2 will go into 18. It does. 2 goes into 18 9 times. Now, does 2 go into 9? No. So we'll go to the next prime number, 3. Does 3 go into 9? Yes. 3 goes into 9 3 times. We know 3 is prime, and so we're done finding the prime factorization. Sometimes this is called the sausage method. I've heard that before. I don't know if it looks like a sausage. But we get the same prime factors, 2 times 2 times 3 times 3. We write those prime factors from smallest to largest, and again, we can use the exponents to write the prime factorization as well. If you multiply those numbers together, you'll get the original number.